Hello and welcome. Today we are going to explore C++ function objects, which allows us to create objects that can be called like functions. Let's dive in. Function objects, also known as functors, are objects that can be called like functions. The example shows how to create an adder class. It has a private integer value. The constructor initializes this value. The operator parenthesis is overloaded to add the internal value to the argument x, and returns the result. Now let's see how we can use function objects in C++. Function objects are objects that behave like functions. They achieve this by implementing the operator parenthesis. One of their key features is that they can maintain a state between calls, making them more flexible than regular functions. They are also commonly referred to as functors. In the code example, we are using the adder functor that we defined earlier. First, we create an instance add5 that adds 5 to any given number. Then we call add5 with 10, which gives us 15, and again with 25, resulting in 30. Similarly, we create another functor add10 that adds 10 to any number. Calling it with 20 gives us 30. Let's discuss the advantages of using function objects. One significant advantage is that function objects can maintain state. Consider the counter class, which keeps track of how many times it has been called. Each time the operator parenthesis is invoked, the count increments and the updated count is returned. Here are some advantages of function objects. They can store state between function calls. They can be initialized with different parameters. They work well with standard template library algorithms. They are often more efficient than function pointers. Function objects work seamlessly with standard template library algorithms like findIf, countif, and sort. The example shows a predicate functor is greater than that checks if a value exceeds a threshold. This threshold can be set when creating the functor instance. This allows for customized behavior within standard algorithms. Let's see how we can use function objects with standard template library algorithms. We are creating a vector of integers named numbers. We create a functor is greater than 15 with a threshold of 15. We then use the countif algorithm to count the elements in numbers that are greater than 15, which will be 20, 25, and 30. Thus, the count will be 3. We find the first element greater than 15. The iterator it will point to 20. We create a different threshold functor greater than 20. We use it with another algorithm partition, which partitions the numbers vector into elements greater than 20 and the rest. The C++ standard library provides predefined function objects in the functional header. This includes plus, minus, multiplies, divides, greater, less, and equal to. In this example, we are sorting a vector of integers in descending order using standard greater. So the numbers vector will be sorted as 9, 8, 5, 2, and 1. Standard functors offer standardized behavior, optimized implementations, a consistent interface, and reduce the need to write common functors. Benefits of using standard library function objects are standardized behavior, optimized implementations, consistent interface, and no need to write common functors. Function adapters modify the behavior of existing function objects. std_bind creates a new function object by binding arguments. std_not function creates a negated function object. std_mem function converts a member function to a function object. In the code example, we are finding the first number in the numbers vector that is greater than 5 using std_bind and std_greater. std placeholder specifies that the first argument of std_greater should come from the range specified in std_findIf, and 5 is bound as the second argument. In modern C++, lambda expressions often replace function adapters. Lambda expressions are more readable and often more efficient than binders. Function objects are commonly used as custom comparators for sorting and organizing complex data structures. In this example, we've created a custom comparator that sorts person objects by age. This can be used with std_sort, std_priorityQueue, std_set, and other standard template library containers and algorithms. Benefits are that it encapsulates comparison logic, is reusable across different algorithms, can maintain state if needed, and is more readable than complex lambda expressions. Let's quickly summarize what we've learned about C++ function objects. Function objects or functors are objects that can be called like functions. They achieve this by implementing the operator parenthesis. They can maintain state between calls, work seamlessly with standard template library algorithms, and are often more efficient than function pointers. They're commonly used as custom comparators for sorting and containers. They can also be used as predicates for algorithms like findIf and CountIf for transformations with transform for callbacks with state, and for building complex operations from simpler ones. The standard library provides predefined functors in the functional header and function adapters like bind. Function objects are supported in all standard template library algorithms and containers. As a modern alternative, lambda expressions are available. When working with function objects, it's best practice to keep them small and focused. Use standard functors when possible. Consider lambdas for simple one-off functors. Make functors const correct, and use functors to encapsulate complex logic. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.